Hello, this is project 10 of the Arduino Starter Kit series. Um, I believe it will be pronounced Zoetrope. In this project, you will make a moving image using a series of still images that rotate around a spindle. Not only will you use a motor to rotate the series of images, you will also be able to run the motor backwards using an integrated circuit called an H-bridge. And this will give you a better idea also how old film used to work. So if you never used old style film, if you're younger and you never really saw uh, the like the old projectors, this will give you a better idea as to how we got motion out of using those projectors. As always, to get to this, you go to tinkercad.com. You log in. You can log in with your Google account or your own account. Click on Learn. Change this from 3D to circuits, and then click Projects. If you click Show All Arduino, it will show you all the projects. I've made videos on all of these and all of these all the way up to Zoetrope. Maybe it's a Zoetrope, I'm not sure. Comment below if you care. So we'll click on that, and as always, I'm not going to spend a lot of time reading through this. I know you can read. I'm not going to make you do that. This is an Arduino. It's a microcontroller. We can hook up wires to it and it connects components to this, which is called a breadboard. And instead of soldering things together, it's a nice way of being able to make things. So I have a lot of other videos in this series. Feel free to check out do them in order. It might help. I do like this. Before the internet, television, even before movies, some of the first moving images were created with a tool called a zoetrope. Zoetropes create the illusion of motion from a group of still images that have small changes in them. This would be also similar to maybe you've made a flip book with a little, a stick figure or something on typically post-it notes or what what students normally choose to use. So what we are going to use in this, if you're doing it in real life or you are doing it if you're doing it with a physical Arduino in person or you're doing it on Tinkercad, we will be using a potentiometer, two 10 kilo ohm resistors, two push buttons, one 9-volt battery, one motor. I think this is supposed to be a separate line, a chip called an H-bridge, and of course your Arduino Uno. All right, and you'll see the setup. It's a lot of wires, so we'll get going on it. You can read those, obviously. I do want to read through this, though. An H-bridge is a type of component known as an integrated circuit. Integrated circuits are components that hold large circuits in a tiny package. This might have used to take up, an entire room or a building, and now we can fit it on this tiny little chip. These can help simplify more complex circuits by placing them in an easily replaceable component. For example, the H-bridge you're using in this example has a number of transistors built in. And remember, the transistors were these electronic switches, right? Very much like relay switches, almost like a light switch, but it's controlled with, in this case, we're sending out, digital power. We're sending like 5 volts to it, and that'll flip a switch, and that can control a higher amount of voltage. To build the circuit inside the H-bridge, you would probably need another breadboard. So we are not, this saves us a lot of time, okay? You could do it. You could have a separate breadboard and put all your transistors together and make it, but this is nice. So let's see this. It's sometimes convenient to refer to the pins by number instead of function. When looking at an integrated circuit, the part with a dimple is referred to as the top, and that's very important. Now, sometimes it has a dimple like this, or it has a tiny little circle I've seen before. You can identify pin numbers by counting from the top left in a U shape like the picture above. And that is very important when we're using these, okay? All right, let's move forward to building the circuit. Obviously, if you set up that integrated circuit incorrectly, it wouldn't work. So we're going to start by setting up our power and the ground. We're going to use 5 volts. We'll run it to the positive rail, make it red because positive should always be red. It keeps us nice and organized. Ground should be black. And then they want us to ground this rail as well. And so the way that works is Now every single one of these is a ground, as well as every single one of these is a ground, and every single one of these is a positive. All right? They don't have us hook up positive yet, so we'll see what happens with that. Next, they want us to connect the two push buttons along with resistors. You'll notice in this case, we have the resistors going onto the other pins of these push buttons. So they are grounding it differently. Now, are these two connected in between? I can't answer that. Could we put the resistor down here? Maybe. Okay, I'm not sure about that. So could that resistor be down here going to ground? Maybe. As far as I know, the push button is just connecting this side to this side. So maybe this is just to keep it organized because we're having a lot of different things. So first of all, we need positive running to the left side. So let's get those push buttons. If it's not showing up, just search for the push button. You could just say button. Let me double check I'm on the right one. So we've got 3. Is that right? Okay. Oh, I had mine over a little bit. Okay, and then they skip 2. And then we're running a positive. And make it red, please. Right? Make it red. Now theirs might be over a little bit. I want to keep mine in line. Remember, you're in charge, right? As long as you hook it up to anywhere on this rail, you're good. This one, they moved over. I'm not sure why that was, maybe just visually. This one's going to run from 5 to 5, and then 10 to 4. So we've got 5 running to 5, 10 running to 4. They made them blue. The reason why they're not red or black is because they are not positive or negative necessarily. They are part of a different circuit. Let me get the resistors in there. They were 2 10-ohm resistors, and they were connected to the right side. So we'll just drag in our resistors. The colors are very important, and it does run to ground, right? It does run to ground. Make sure your colors match. Otherwise, you will have the wrong resistor. The way to do it on Tinkercad is you just click here and make sure it says kilo ohm. Then you type 10. Once again, you can always search on a website, look up color code for resistors, and you can enter your colors, brown, black, orange, silver, or whatever that is, and it would tell you your resistance values for that resistor. So if you have those in real life. So I believe we are all set up there. Wonderful. Once again, the way this works is there's power running to this terminal, I believe to this terminal as well through it. When we push the button, the electricity runs to this side, I believe both, and it will run to the terminal number 5, and this one will run to terminal number 4. Now the resistors are there to divide the voltage, as far as I know, to make sure that that this gets a good read, okay? All right. If you need more details on that, look in the description. I'll link a Wikipedia. Moving forward, we put a potentiometer. If you don't see potentiometer, just type potentiometer. And the potentiometer is going to be connected. The center will be 14. That'll be the easiest way for me to find it. The center is 14. So it's going to be right here. And if you mouse over, you can see terminal 1, wiper, and terminal 2. We'll see how that's connected. Let me check. We are going to ground the one on the right. We are going to send positive to this one. And then the middle one, they connected it to that side. Our potentiometer, in this case, is on this side. So we're going to run that to analog input 0. So let's do that first. I'm just going to run it here. Analog input 0. They had it purple, and I like keeping it the same color. We do have a positive running to this terminal 1, so that should be red. If you're doing this with your Arduino, you do not need to match the colors perfectly, okay? If you don't have a purple, it's okay. You don't need to have a purple, okay? So now what we have is positive running through this potentiometer all the way to ground. The way this works is a potentiometer is a variable resistor. So as we turn this, it will be more or less resistance, and therefore this will take a reading on how much resistance there is. Therefore, knowing where this is in its cycle from this side to this side, and it will affect something. I would imagine it's motor speed, but we'll see. All right, moving forward, we're going to add that integrated circuit. Now, here we're going to type H-bridge. If you have, oops, maybe just H. Let's see. Maybe not. Let me check. Place the H-bridge in the breadboard. Okay, maybe it has to be a capital H. All right, it had to be capital H dash. Now, I believe the one that comes with, and let me make sure I'm putting in the right spot. Okay. I believe the one that comes with the Arduino starter kit is going to be the same. The numbers you would want to check. Now, what you can do, if you have different numbers, you could cross-reference. So you could search those numbers on Google. They're going to be tiny, okay? But search those numbers on Google, and then you could see if it's the same integrated circuit. But hopefully it matches. And then you'll notice the little dip thing is here, and then there's a dot marking terminal number. Oh, I wish I could do that without my mouse there. It says 1 and 2, input, output, right? But this one's telling us what every single one does, but we can just count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Okay. So breaking it down, this pin does connect to number 9. So let me show you that. So we're going to do this to there, and it was blue. Now, let me talk about why that is. All right. So if I see here, this is enable 1 and 2. So we'll go there in a second, and it might be an output to enable 1 and 2. We'll see how that goes. The next one, you'll notice the pin number 2 is connected to number 3. So pin number 2 is connected to number 3. You could connect it any of any of these. They're all the same. And it was blue. Just want to keep it nice and organized. This one, it says, is an input. All right, input number something. I'm having trouble with my mouse. Input 1. So this will probably be an output, sending a signal to that. Then we have nothing is connected to pin number 3. 4 and 5 are grounds. Now, I am hoping, we'll see, you'll notice these are red. They shouldn't be if they're actually grounds. So I'm going to check those. So that's pin 1, 2, 3, 4, and 5. So if we go 1, 2, 3, 4, and 5, this is a ground, this is a ground. So those should be black. Those should not be red like they have, just because that's confusing. Okay, black should always be ground. Wonderful. So now that makes a little more sense than what they have. And then they have this pin. So I think that was 5, 6, 7, maybe the second from the end. If I mouse over it, we'll see, but it's running to number 2. So the second from the end runs to number 2. Now it was blue as well. And so I will choose blue. And if I mouse over it, it says that's an input. So this will probably be an output to send signal to it to give an input. Now, the only other thing that we're missing is they had a positive running to that pin. Now, if I mouse over that pin, it says the power. So that is the main source of power for this integrated circuit, and we want to run it to the positive rail. Now, I'm going to run it on an angle just so you can see it a little bit better. There we go. So we've got power running here. Apparently, this can enable something. This is an input for some reason and an output. So this is input 1, output 1. So I'd imagine if you send a signal into here, electricity will come out of here as long as there's power coming here. Then we have 2 grounds, which need to be there. And then there's an input number 2 and maybe an output number 2 somewhere else. I'm not sure where that was. Maybe I skipped it. Was that here? All right, well, we'll get to that. All right, moving on. Moving on to the next one. So you can read through these about the integrated circuit. Is that the same? Okay, it just goes through the exact, like why we would do those things. So please feel free to read through those. It might actually answer some questions that I didn't. And now we're going to hook up on those empty ones, right? We have a ground and a positive. We're hooking up to 22 and 25. So we need our motor. So you can search for motor. And because we need our motor, if you watch the last one, you now know that we need a 9-volt battery source as well. So this doesn't matter where it is. I'm going to put it to the side just so we can see it. If you mouse over, you'll see terminal 1, terminal 2. It does not matter which one is positive and which one's negative. It'll just make the motor spin a certain direction. So in this case, with the pictures you might use, it might matter. One will be forward, one will be backwards. We are running our what presumably would be a ground to the 3rd pin. And if I go to the 3rd pin, that is an output. So we're running that there, and we're saying it is black for right now. And then this other one was running to 25, which if I look on that, that's another output. And that, for some reason, is going to be red. Let me make sure that's correct. 25 and 22. Okay. All right. Now we will move forward. Next, plug the 9-volt battery into the top voltage rail. That's why we didn't give positive source here. This rail is 5 volts. Okay, this rail is 5 volts. This rail is nothing right now, but it's going to be 9 volts. Okay, and we don't want to mix up 5 and 9 volts. If you send 9 volts into your Arduino, it might burn out the board. I'm not sure exactly how much it can take on these inputs, but it's supposed to be 5 or 3.3, I believe it was. So now we need a 9-volt battery, and I don't see that. Not sure if you can hear my son making silly noises. Let me just search battery, I guess. Oh, there it was. All right, a 9-volt battery. So we'll take that 9-volt battery out. If you're doing this in person, you would want to, obviously you'd be able to get a real 9-volt battery. Make sure it's fully charged, okay? Now we can rotate these. I can't remember how. Let's see. That's not it. There is a way to rotate these, and I can't remember it. If you remember, if you know, please tell me. Otherwise, I'm just going to throw it up top. Okay, I'm going to zoom out for now. And we'll just know, hey, that 9-volt source is connected. So we have a positive and a negative. The positive has to hook up to the positive rail, and it should be red. And then you'll notice they do have the negative going to negative as well. The reason why that is negative is just ground. The positive is what gives that voltage, and we don't have, as long as we're connected here, anywhere it runs ground, it's not going to burn out our components because it's ground. It's okay. But if we run 9 volts of positive into something that, like this integrated circuit input or the power source, that might burn out the integrated circuit, right? And we don't want that to happen. So now moving on to the code. As always, I use the Arduino editor at create.arduino.cc. Once you log in, you can go to the examples, starter kit, and then Zoetrope. I use this because it has the notes in it. It was created by Scott Fitzgerald, and he did an awesome job. So you can go through this, and please do. If you have any questions, it might answer some of them, but I will go through the basic code. I'm going to erase everything here and paste. When it's a little bit more complicated, but I'm going to assume that you watched the other ones. So I'm not going to walk through it as in depth on each one. So we start this integer control pin. We're calling it control pin 1 is number 2. Control pin 2 is number 3. And something we're calling an enable pin is number 9. That's identifying this as enable pin. Direction switch pin is number 4. And you'll notice that's connected to this button. On-off switch pin is number 5. So if we look at number 5, so this one will probably turn it on and off. This one will turn it forwards or backwards. And then pot pin, which is our potentiometer, is analog input 0. Moving forward, we're creating some variables just to hold values. On-off switch state, they want it to start off, right? 0 means low or off. Previous on-off switch state, they want it to be off. Direction switch state, off. Previous direction switch state, off. Now, some people ask, do we need to add those values in? Yes, in order for this to work. Otherwise, it might just assign a random 0 or 1 to it, and it may not work in the programming. Then we have motor enabled, something we're calling motor enabled, and we're saying it's off right now. Motor speed, we're saying 0, it is off. And motor direction, 1, that's like high. It's just saying motor direction equals 1, and we will define what that means later. Okay. Now we're saying pin mode on the direction switch pin is an input. So if we look up there, direction switch pin is number 4. This is an input. It's reading if the button's been pushed. On off switch state switch pin number 5. And that is an input. It's reading if this button is pushed. Control pin 1, which is number 2, is an output, so it'll send a signal out. All right. Control pin 2 will send a signal out. And then enable pin, which if we look up here is number 9, this one is an output as well. So all these are outputs. These are inputs. And I'd actually, if I was redoing this, I would actually change these. You don't have to. But maybe I say, the greens are inputs and the blues are outputs. All right. Moving forward, pull the enable pin low to start. So they're saying this is the void setup. This is when it begins. It runs it only one time, and it's saying please make sure the enable pin, which is number 9, okay, number 9 is low, meaning it is off. And then repeat this set of directions nonstop. So read the value of the on-off switch. So on-off switch state equals digital read. So it's reading it, okay? It's seeing is it on or off? And then store that value into the switch state, okay? So then we know, is that switch on or off? Then read the value of the motor and divide that by 4. It says read the value of the potentiometer, and divide by 4 to get a value that can be used for post-width modulation. As far as I know, that's just something you need to remember, that if you're reading off the potentiometer, that you need to divide by 4 if you want to use it for post-width modulation. Now, post-width modulation is the way a digital output can act like an analog output. So it sends variations of on-off depending on which what we choose for that post-width modulation. So it's turning on and off at a certain rate, and that'll make things either go faster or slower or be brighter or dimmer, or it seems almost like it's more voltage or less voltage. All right. If the on-off button changed state since the last loop, so it's saying if the on-off switch state is not equal to the previous on-off switch state, and if the on-off switch state is high, then enable the motor. Then motor enabled equals not motor enabled. Interesting. This is something I need to look into. So I will look into that, and I'm going to post something in into the description as to why that works. So if the on-off switch state button changed since the last loop, change the value of motor enabled if pressed. So if it's pressed, it'll be changed. If the direction button changed state since the last loop, same thing, right? Change the value of motor direction if pressed. So this is dealing with the on-off button. This is dealing with this button. And then the second one is dealing with this. And it's doing the exact same thing. It's saying, hey, if it changed, change the value. If it didn't change, don't do anything. All right? So if we press it, it'll change the value for motor direction. If we press this, it'll change the value for motor enabled. But if it doesn't change, don't do anything. All right, then we move forward. Change the direction the motor spins by talking to the controller on the H bridge, to the control pins on the H bridge. So I'm going to move my camera over. All right. So if we're looking here, it says if the motor direction is equal to 1, so meaning, remember we did start it off as 1. Motor direction equals 1. So if it's 1, then digital write, control pin 1 is high, control pin 2 is low. So they're saying control pin 1, I'm sorry for having to go back through this, 2, they're saying, okay, if the motor direction is 1, then this should be high and this should be low. Else, make this low, make this high. Now what I'm imagining, and if we look in here, this is input 1, this is output 1, this is output 2 and input 2. So what it's saying is if there is electricity being sent here to the motor, make this one 0 or like a ground, right? So the electricity can flow this direction, right? It acts just like a ground and the electricity can flow in this direction. However, if this one is high and it's sending out electricity this way, then allow it to send the electricity here. This needs to be like a ground. So I don't like these colors. That was my issue before. So I almost want to change it to like the same color, because it changes what it does based on what these outputs are doing. So if this is high, then this one is low. So the electricity can flow. Okay, it'll flow in that direction. Maybe the motor will spin clockwise. Then if this is high, electricity is flowing this way, maybe the motor will spin, it will spin the opposite direction to the ground over there. Hopefully that makes sense. If the motor is supposed to be on, so if motor enabled equals 1, which was defined by pressing, I believe, this one, right? Post width modulate the enabled pin to vary the speed. So then they say analog write to the enable pin, and once again the enable pin is number 9, so we have number 9 right here, right? This controlled the direction. These two controlled the direction. This one is going to control, I believe, the speed. So number 9. Okay, and make that equal to the post width modulation, that reading of motor speed. And remember, motor speed was just the reading from the potentiometer divided by 4. So what it's going to do is it will send out, as we turn this, it will send out different, I think I've been saying post, I'm sorry, different pulse width modulations. Pulse width, maybe that makes more sense. It'll send out different pulse width modulations, changing the speed of this motor, because it's almost like it's sending out more voltage. But it's always sending 5 volts, right? Is it? It's not, because the motor is actually receiving 9 volts. So it's pulsing, having this integrated circuit sending out pulses of 9 volts into there, and the more pulses, the faster it'll go. The less pulses, the slower it'll go. I'm sure there's an engineer that could comment on that and give more specifics. All right. Then, okay, so if the motor's enabled, then do that. Else, so if the motor's not enabled, analog enable pin 0, so it turns off the enable pin. Then it says, let's just save the current on-off switch state as the previous. So previous direction switch state equals direction switch state, and then save the current switch state as the previous. So basically, because in this programming, it was reading whether this is on or off, and this is on or off, we need to store that value before it loops back again, because if we let go, we want it to know we let go, and either switch the direction of the motor or turn it off. All right. So there are some more steps that I will not be going through. Please read through that if you have any questions, and then feel free to ask in the comments. And then the last step, and I guess I could have run that. I'll run it for you in just a second. So to run it, you have the code. I do like having the, interesting. I like having my, the analog read up as well, but I don't have that option right now, maybe because I didn't turn it on. But when we start the simulator, you'll see nothing's happening. If I push the button, remember this is the on-off, it starts spinning. Now I believe it's turning left. The problem with the simulator is it actually sets it up so it gets that weird effect, like watching rims on a car down the highway in a movie. It looks like they're going backwards sometimes. So I'm not sure. So let's click this. This should switch the direction, and it did. Awesome. You'll notice it's going negative 16,530 RPMs. If I press it again, it'll go positive. All right. And then this potentiometer will change the speed. So I would imagine this is the least amount of resistance. You'll see it seems to switch directions. It doesn't actually. And then this is the most amount of resistance. And so it's getting a different read depending on where you are. Awesome. So then it talks about building the Zoetrope, and I can't do that with you. You would cut this out. This comes with the kits, okay? And you would spin something on top of it. It comes with the kit. It looks just like this. Let me move this out of the way. It would spin around. In this case, it looks like you'd see a flower growing or something. All right. So that is not something I can do for you. You could draw your own drawings in there and all that stuff, and it would look pretty cool. It's a really nice way. I've used it to show my students just to get them interested in Arduino. So I hope that was worthwhile. I think a couple parts there I got a little long-winded. I apologize for that. Yeah, so I will work on getting the rest of the videos out there as soon as possible. Have a wonderful day, everybody. Thank you. Oh, and hey, if you know anyone interested that could benefit from my channel, please feel free to share it with them. The more people that subscribe, the more I know that this is worth my time. And I definitely want it, I want things to be worth my time if they're worth your time. So have a great day.